In this lesson, to find the area of a triangle, we are going to learn a new principle that how do you use coordinate geometry to find the area of a triangle. Okay, but let's recap what we have learned about finding the area of a triangle so far. Okay, so take a look at this diagram ABC, our triangle number 1. And let's say this is a right angle triangle and we have been provided with these two dimensions. One which is the height and the second which is the base, right? And the area calculation is extremely simple. 1/2 times base times the height, correct? Now this formula can apply on any triangle in general as long as we know the value height and the base, right? Now take a look at this second type of triangle in which we don't know what exactly is the height of this triangle, but we know 3 dimensions. 3 dimensions meaning the 3 side lengths of this triangle, A, B, and C. We know these values. So in this case, we said that the area of such triangle in this case can be found by the application of a Heron's formula, which is S times S minus A times S minus B times S minus C. And this whole thing comes under a square root, where the value S is equal to half of the perimeter of this triangle, right? So this was one good fundamental rule we learned about the application of Heron's formula. This was very helpful at times. Now consider a third case in which you are not given any of these dimensions, but rather you have been provided with the vertices of a triangle in an xy coordinate plane. So vertex P has value x1, y1, vertex R has value x2, y2, and vertex Q as x3, y3. So you have been provided with these 3 pairs. In this case, how would you find the area of such a triangle? Well, you could say that since we have 3 vertices, we could easily find these 3 dimensions, the dimension A, B, and C, the length of each side of this triangle, and we could simply apply this Heron's formula in this case. Well, you could do that. That is definitely one option, but it is a time-consuming process because you literally have to find 3 distances. You have to compute 3 different subtraction, squaring, and taking square roots. But rather, we have a very simple and an effective formula. We will find that the area of a triangle when you are given the vertices can be computed using this relation in which we take the value x1 and multiply that with the difference of the y coordinates of the remaining 2 vertices. Then you take the next coordinate x2 and multiply that with the difference of y coordinates of the remaining 2 vertices. Then you take the third x vertex and multiply that with the difference of the y coordinates of the remaining 2 vertices, right? But the important thing here to keep in mind is about this sequence, that you take x1, then you take y2 and y3. You see, the sequence is 1, 2, 3. Then you take x2, and then what comes after 2? After 2 comes 3. Then the only remaining vertex is y1, right? So you follow the sequence 2, 3, 1. Then you take x3. What comes after 3? Because you are kind of going in a clockwise fashion. After 3 comes 1, and then you go y2. So 3, 1, 2. Or if it helps you, you can build a very simple relation like this. Let's say these 3 numbers, the 1, 2, 3, are organized in a clockwise fashion like this. All right. When you take x1, you're left with 2 and 3. So you take y2 and y3. This is exactly what you have here. When you take x2, then you follow the clockwise sequence and then you take y3 first and then subtract y1 from there because 1 comes after 3 in this clockwise arrangement of numbers. Correct? When you take x3, which is here, then what is the first number you see after 3 in this clockwise arrangement of numbers? You see the value 1. So you go with y1 and then you take y2, which comes after this one. So the point is you follow this sequence of 1, 2, 3, 2, 3, 1, 3, 1, 2, which is going in this clockwise fashion all the time. So using this formula, you can very easily find the area of a triangle. You don't have to go through very extensive set of computations, but you just multiply some numbers, multiply that with half, and then this is your area. Very simple and very straightforward. Let's go apply this formula in next 1 or 2 examples and we try to understand how exactly we want to use it. So let's take a look at this example in which we are supposed to find the area of a triangle whose vertices are 3, 4, 6, 3 and 2, 8. Right? Now I have this XY coordinate plane just for the reference if you would like to draw a diagram. You don't have to, it will save you some time. But the important thing is labeling these vertices in 1, 2, 3 fashion. So this is my x1, y1, this is my x2, y2, and this is my x3, y3, right? Now let's first write down our formula for calculation of this area. The area is 1/2 times, let's follow the rule 1, 2, 3. So x1 times y2 minus y3 plus x2. The next comes after 2 is 3, so I'll take y3. The only remaining coordinate is y1. Then I will take x3, right? Then I will take y1 because after 3 will come 1 and then you subtract y2 from here. This sequencing of 1, 2, 3, 2, 3, 1, 3, 1, 2, this is very important because if you reverse these numbers, then you will get the wrong result. That is the only precaution you have to take in this example, right? Right, now let's plug in these numbers based on our formula and calculate our required area. So that will be 1/2 times x1 is 3 and y2 would be 3 minus y3 would be 8, 3 minus 8, right? Plus x2 is 6. Then you have y3 which is 8 minus y1 which is 4. Plus x3 is 2, then you have y1 which is 4 minus y2 which is 3. So you have plugged in all the numbers. The remaining is a very simple computation. So 3 minus 8 is -5 times 3 -15 plus 8 minus 4 is 4 times 6 is 24 plus 4 minus 3 is 1 multiplied with 2 is just 2, which will be 1/2 times 24 minus 15 plus 2 is 11, which is 5.5. So the area is 5.5 square units, whatever those units were, whether they were centimeters or inches or however we define our XY coordinate plane. So you see that once you have the coordinates defined of a triangle, it is very simple and fast to compute the area of a triangle using this formula.